In this video, we're going to talk about the use of the law of sines and cosines to solve a word problem involving an inscribed triangle that's inside a circle. So here you see both laws listed, and I want to focus on the law of sines first. The key with the law of sines is you have to have a pair of values, meaning, look at this triangle here that I have. You have 35 degrees, but the side opposite you don't have. You have 12-degree length, but the angle opposite you don't have it. So the first thing you have to do is recognize that you have to get a pair of values. Fortunately, when we're dealing with triangles, we can use the fact that the sum of the angles is 180 degrees, and therefore we can get that missing angle as 70. Now, folks, we have a pair. We have an angle and we have the length of the side opposite. We are now ready to go ahead and use the law of sines with the pair that we have, and we could set up this ratio which would allow us to cross multiply and get our x value. Let's quickly review the law of cosines. And what I want to point out is that when you are picking an equation, your side that you're dealing with is going to be opposite the angle in question, and the other two sides are going to be your a and b. So I'm going to be using this bottom form of the equation. We're going to try to find the length, c squared, and that's going to be opposite this 40-degree angle. So my formula is going to look like this. C squared equals 12 squared plus 14 squared minus 2 times 12 times 14 times cosine of 40 degrees. And when you set this up, what I want to emphasize is that these a and b values are what form the angle in question. So if you keep that straight, you will never get confused. The a and the b form the angle in question, and then this side is going to be opposite to that angle in question. We are given a triangle with angles 35 degrees and 50 degrees is inscribed in a circle of a radius of 10 centimeters. Draw the triangle and find the length of all three sides. Okay, so let's quickly review angles and circles, etc. If you have an angle within a circle, you could have a central angle here where the vertex is on the center of the circle. That is a central angle. So as the name implies, the vertex is on the center. In that case, the length of this arc matches the degree of that central angle. So the easiest thing to do is focus on the 90-degree central angle, and it's clear that this is 1/4 the circumference of the circle, and 1/4 of 360 degrees is 90 degrees. Now, things change when you have an inscribed angle, which means the vertex of the angle is on the circle. So if we are using this same diagram to match these points, which capture 90 degrees of the circle, this is going to be 45 degrees. So when we talk about these angles, we're going to use the amount of circle that is captured by the angles to draw our initial triangle before we even consider finding the lengths. Really quickly, What confused me when I was first doing this is that not only can you have a degree measure of an arc of a circle, but you can also have a length measure. So here, if our radius is 10 centimeters, the circumference would be pi times diameter, which would be pi times 20 centimeters. And if you're only talking about 1/4 of the circle, this distance would be 5 centimeters. So again, when you talk about arc of a circle, you can talk about it in terms of length, which would be a portion of the circumference, or you can talk about the degrees of the arc. Let's use this calculator on GeoGebra to look at some inscribed angles. Now this calculator is very jumpy, so I apologize if the size changes. I can't quite figure it out. But look at this inscribed triangle. Now I want you to notice something. Look at the center D. Here, where they have A, B, and C on the triangle, this inscribed triangle does not include the center. But if we move this point here, now the center is within the triangle. Now, the second thing I want you to notice is the arc that is captured by each of the angles. Let's look at angle A. The arc opposite angle A runs from here to here. Okay, now I'm going to move this a little bit so that it comes through the center. So this inscribed triangle includes the center. This one has the center outside of the triangle, and this has the center inside of the triangle. Those are your three possibilities. Okay, now look at this. If the center is included inside the triangle, okay, I want you to look at angle A. Look at the arc that's captured by angle A on the opposite side of the circle. Okay, so here's angle A. Here are the lines of the triangle that create angle A, and here is the the arc that is captured by angle A. Notice that it's less than 180 degrees. If it was 180 degrees, it would look like this. But this is less than 180 degrees. There's that calculator jumping, I apologize. So if this angle is less than 180 degrees, if this arc is less than 180 degrees, if this arc is less than 180 degrees, if this arc is less than 180 degrees, that means all of these angles have to be less than 90. Now look what happens when you have an arc greater than 180 degrees. Okay, let me make that clear. All right, if we're looking at angle A, this captured arc would be 180 degrees. That's why angle A is 90. If we make angle A greater than 90 degrees, okay, how do we know that? Because this captured arc is now greater than 180 degrees, then the center is no longer in the triangle. So let's use that information to build our triangle. Okay, here we go. If one of the angles is 35 and one is 50, then we know that the third angle is going to be 95 degrees. That is greater than 90. That means this center is not going to be in our inscribed triangle. Okay, so the first thing we're going to do is we are going to create the 95 degree angle, and we're going to use the arc to do that. So this arc, if you multiply 95 degrees by 2, that arc is 190 degrees. Okay, exaggerate it a little bit because it'll make it easier to do the drawing. Okay, that means that yellow is the captured arc, and we're going to put this point on the circle, and this is going to be our angle A right here. So this angle right here is 95 degrees, and the arc that it captures is 190 degrees. So by definition, that center is outside the triangle. Okay, if these are two sides of the triangle that create angle A, then this must be our triangle right there. All right, so one of these is going to be angle of 35 and one is going to be 50. I'm going to call this the 35-degree angle, and then we're going to call this the 50-degree angle. That means this arc captured opposite to the 35 degrees is going to be 70 degrees here. This is 70 degrees of arc, and this final portion of the circle here, which is opposite the 50 degrees, is going to be 100 degrees of arc. And when you add 190, 100 is 290, and 70, that's 360 degrees of arc. Now, we're going to draw our radius in. So here's our radius right there, and there's our radius right there. And both of those are going to be 10 centimeters. All right, let's call this point B, and let's call that point C. And let's call this center D. Our goal is now to find the lengths of this triangle. Now, the title of this video suggests we're going to use the law of cosines. So if we're looking at this triangle here, right, we already know that this radius is 10 and that radius is 10. We're going to use those two sides to find this length first. Okay. Length BC. And to do that, we're going to use the law of cosines. Here we have an angle, what's called angle C, and we know that this length, which is opposite to it, okay, I'm going to call this capital C, and let's change that letter because we got too many C's here. Let's make this E. Okay, we know that that angle C and this length C is formed by the two 10 centimeter lengths. So we're going to call little c squared, that's the length, is going to be 10 squared plus 10 squared. These are the two sides that form the angle, minus 2 times 10 times 10 cosine of angle C. So this is going to be our equation to find that length. Now, we have a problem here. We have two unknowns. We have C, the length we're trying to find, and we have big C, the angle. However, we know what that angle is. Folks, this is a central angle that captures this green arc and that red arc. This green arc is 100 degrees. This red arc is 70 degrees. That means that that angle C is going to be 170 degrees. So now we have one unknown and one equation. Let's clean this up a little bit and revisit this. Okay, we've cleaned things up a little bit, and recall that C refers to this line here, BE. That's one of the lengths of the triangle. And when we do our math, we get this. Plugging in cosine of 170, etc., we get this length to be 19.92. Okay, now that we have that blue length and we have an angle opposite to it, that allows us to use the law of sines. So the key is with the law of sines is you have to be able to pair up a length and an opposite angle. And once you do that, you are able to find the other sides. Okay, so let's create our first ratio. We are going to have the fact that the sine of 95 degrees over the length opposite, which we know to be 19.92, is going to equal the sine of 50 degrees opposite this side here, which is going to be length AB, and that is going to equal the sine of 35 degrees paired with the side opposite to 35 degrees, which is line AE. When we go ahead and do the numbers, we get the following fractions, and when we place all the calculations in the calculator, we get the length of 15.32 for AB and approximately 11.47 for AE. So now we have all our three sides. One quick thing, little shortcut, when you're trying to find AB using a calculator, you simply enter 19.92 times 0.76 divided by 0.996, and that'll give you this number.